feature KDE Connect.
Okay.
So I can use it as a mods.
Yeah, I do these things a lot.
Using the phone. Yeah, that's KDE. So we can, okay. So it's nice to meet everyone. So today, my name is James. Today we'll be talking about the Linux permissions, and we talk a bit about the whole Linux ecosystem. So, and just the introduction, Linux is a kernel, an operating system that runs on a kernel. And for an operating system, we need files to interact with. And for operating system, we need users. And the users, we have your Windows users, your Linux users. And the users, they need to have permission to access some files they could access. And also, just the whole feature about permission. You can't just grant everything to everyone. So we start with the slide, getting started with Linux. We'll go to the next one, which is, so the goal here, to understand Linux and Unix security model, and how a program is allowed to run, where the user and group information is stored, and the details of file permissions. So the next one, like I mentioned, they have users and groups. So when we come to an operating system, we need to have users, just like your website as well. You have users, people that use the application, people that use the operating system. So in Linux, we understand users and groups. So we can categorize users to a specific group, and we can have users that are just independent on their own. So a user can belong to several groups, just like categorizing them, so you can maybe treat them in a certain way or give them certain permissions. So we have them, and a file could also belong to a user or a group at a time. So I could create a file and call it, any file name I want to call it, a text file, and say that it belongs to Mr. Sante. And when he has that file has an ownership of him, he owns the file. Then he also has permissions, in that permission to say who accesses the file or not. So now we have a particular user that we call root. Something has to start from somewhere. So we have to, a branch doesn't sprout all over the place, it starts from somewhere. So something has to start from somewhere. In the beginning, there's a phrase I use, in the beginning there was a shell, where it was void. Someone started it. So in the beginning there's root user. So the user that could do anything on the operating system, a God user. It could modify, it could break the system, it could delete any user. So in Windows, we know them as administrator. So we have a root, which has a user ID of 0. Each user has a separate, a unique ID. So the more, I think the IDs are incremental. The more users are created, the more ID increases. But 0 is the root user, is a reserved ID for the root user that the system creates. And every password, very soon I'll go to the technical part, but let's just do the theory. Every password is saved on this part. And sorry, not the password, this is the users, etc password file. This file contains all the users in a Linux system. Every user, both the virtual one, both the ones that you don't know about, because some applications, they do create users for them to able to give permissions and seclude their files from other users. So only the root user can change the ownership of a file. So like I mentioned, that there's a file I gave to Mr. Sante. Mr. Sante cannot give the file to you because he doesn't have that permission. He can't assign that file. Only the root user can say he's taking up the permission to give to another person. But he can change the permission of his own file. He can say, I want you to read my file, but you don't own the file. So the only person that could change it is the root user that can change it. So now we go to the user information on the etc file. I'm just going to pull up the terminal here. If I'm able to do this, I'm able to come into here. Okay, well, we have my terminal. Okay, can you see this here? Yeah, Zenbook is the name. Let me try to expand it. Okay, so we have the shell. Like I mentioned, that the shell is the beginning of everything. So I can type here to, to clear this. Sorry? Oh, it was a project I was working on. Yeah, so I just shifted from the directory. So just to talk about the password file, so I could also type this. Let's say I'm going to etc the file I mentioned, the password file. By the way, the feature I'm using to type here, it's KDE Connect. So it's a KDE is a desktop in Linux. They provide this feature for you to connect your phone through Bluetooth or wireless, and then you use the phone as a peripheral for typing, just like I'm using here. So this is the file it exists. I actually didn't type to edit it. So let me just put the content here. Less. Yeah. Okay, enough file. Let me put that properly. No, I missed the how to use that. So let's say the password file is this one. I'm still using ls. I'm still using nano. And then yeah, nano something. Okay, so we have the file here. So like I mentioned that this file contains a user. So we see that the first user is a root, which is the ID is 0, and the root folder, and then the shell that it uses. So we see that root has, it has a password, which is the X. Then it separates by a colon, and the next one is the ID. This next one, it's the group ID that it's created. If I'm correct, I'll go back to the slide. Then the next one is the folder that belongs to the home folder. We call them a home folder. So when you create a user, you give it a home folder, and that home folder is where they have access to all their files, and then the shell it uses. So not to go into detail here, I'm just to show you the list of users the user created, the system created. There's bin user. I'm sure I wasn't the one that created it, but you see that the system created it, and it doesn't have a shell, no login. That user cannot log in. It's maybe a virtual user that cannot do a lot. So this is just to show you here. So I'm going back to the slide. And let me see. Okay. So it contains the user information. The password info is in shadow file. That's the most file you don't want to be compromised in Linux. Then we also have the group, which contains the group details of the group, just like the password file. So the password and the group divide data using the colon, like I mentioned. So let's break it down here. We have a user called Joe, and Joe here has an ID of 1000 and a group of 1000. This is his name. These fields are for extra metadata that maybe the user space wants to store about the user. That's how your desktop, your Ubuntu stores your name, your email. These are the extra fields you use for that. Then this is in the home directory and the bash. So this is the group that Joe belongs to, which is the ID, the primary group. When you create a user, it creates a group called Joe. So now let's go to the program. I don't want to go into details. We are talking about permissions. So a program may be run by a user when the system starts, or when the system starts, or by another user. So a program is your executables, your scripts, your compiled languages. They are all programs. The executables. And before a program starts, the kernel has to check if the file is containing the program accessible to the user or the group. So I'm logged in as James. I'm trying to execute a file that's owned by you. It wouldn't run because you're not permitted to do that. I don't have that permission. Unless you tell me that, you tell the kernel that any other person can run this application before it allows that. So the file, if it's accessible, does the file containing the program permit execution by the user or group? So in most cases, while executing a program, it inherits the privileges of the user and the process that started it. So that's how it runs. Then we go to the next one. A program in detail. When we do an ls, we see the program where it's stored, who owns it. So we go to the next person, what all these things means. So when you do an ls, we see this. So we are going to interpret this. The first one is the file permissions. So in the file permissions, it contains the permission for this program itself. The next one is the link count, number of links that are linked to this, this file. Then we have the owner of the file, which is root. Root created it. The group, which is also a root. When a user is created, it has its groups. So this is the root user. and then this is the file size in bytes, the modification dates, and the file path and name. So we go that the name of a group that has a permission in addition to the file's owner name, that's the group, the owner, or the file, and then the file permission to break it down. That if the first character is dash, it means it's a file. If it's D, if it says if it's D, it's a directory. If it's C, it's a character file. There's a lot of them in the kernel. So, and the first one is dash indicates a regular file, it's an ordinary file. So, and the D indicates a directory. The second set of 3 characters represent the read-write execution groups of the file owner. To take note of the first 3, the arrow -x is for the user, then the second 3 is for the group, and the third 3 is for the others. So when I mean others, it's people that are not in the group and not a user. So they're others, they're public. So the read-write execute, which is arrow, W is missing, means that the owner of this group cannot write to the file. So, but he can execute it, and actually no one can, both the group and the others. They could read it, they could execute it, but they can't write it. So let's take a quick example, and this. Let's see. This one. So I'm going to create a new file. Let's say let's go to my temporary directory where I can play around. So I'm going to create a new file, say test file, and this is the hello world. It contains hello world, and I save that file. And if I go to ls test file, sorry, I typed wrongly. Test. So we see that that's my username .jajo. I can read, I can write, but I can't execute because it's not an executable. It's just a text file. So we can see that my group can read it, but they cannot write it. And others, when we say others can read, but they cannot write it. So I'm going to switch to another user. I think I have a test user somewhere. And to do that, I'll just open a new tab. Let me say sudo. So let me see, I have a test user somewhere. Put in okay. Yeah. Hopefully, my caps lock is not on. Okay. Oh, okay. This is not my root password. This is yes. So this is a test user. I was putting in my root password instead of sudo. Okay. So this the test user is different from the user that created the account. So let's go to the file that I created. So I would cd into tmp and say ls test file. So I have to put the edge. Sorry, L. So it sees that it's on Jajo. So let me try to write to this file as another user. You see that if I do test file, you see that it's unwritable because I didn't create the file. It was another person. So if as the owner of the file, I could change it to he won't be able to read it. So if I move the root read permission, the user cannot read the file, cannot write it. So this is just the basic of this part. So we continue to the slide. So yeah, the write is arrow, W is read, and X is execute. So going to the next part. So like I mentioned, the file is owned by the user, file permission, and the read write executes. I already explained this part, and we go to So what I mentioned about the beginning of the ls, the dash means a regular file, and D is a directory, L is a link, symbolic link, X is for Unix sockets domain, and P is for pipe, C is for character device. I think there are more than this. So if you're writing to the kernel space, you see a lot of it. So in the owner and the group column, you see the S, the sticky bits. So this one is more advanced, but not it's a special case where you want to run the file as another user. So when the kernel is running it, actually runs it as another user. So yeah.
We can go over that.
So set GUID. Oh, okay, okay. Okay, yes, yeah.
So when
Yes. Yeah, the sticky bits parts because it's tricky. You can't you don't really see it. The sticky bits when they change a code to run as someone else, it runs as root and start modifying files. Meanwhile, the file is for someone else. And so we go to the next part. So the file permissions. There are two ways to set file permission. So the one is using chmod and then specifying the user readable format, G plus X, G plus the other one. So let's go down to, when you mean G means a group, U means a user, and O means others. So you specify the identities that you need to give permission to, then add a plus, and either X for read, W for, you can add multiple at the same time like we have this part. So you can also say the user, you're granting it, plus is a granting, read and execute. So it gives the user read and execute, and write and execute, sorry. So we also see that the G plus X gives the group the access for executing, which is the end there that we see. So when we go with UG, it means both the user and the group should have an executable access that we see here, and then we see that they have, wait, okay, it's minus, sorry. So when it's minus, it removes the X executable access for the user and group. So we see that in the first two, they were given the executable permission, but in this part, it was removed, and this is the output. So that's basically how to set a permission. So I'm going to get a bit, so we just see how it's done practically. So I'm going to go back to this file. As the creator, I would give a write access to others because test user is not in my group and it's neither is it me. So I'll just do a change mode. I will do that O, which is others, plus write test file. So this is, oh, I'm sorry, I just have to increase this. I could have done that a long time ago. So that is better. Okay, so we see that the chmod, I'm giving others a write access to this file. So when I click on enter, it modifies. So when I try to run this permission again, we see that the test user for these parts, you see that we have arrow W for others, which is the last tree for others. So if I go back there as a sudo, as a test user, and I try to modify the file now, it would no longer give me that error. I can now modify the file because I'm another user. So the owner of the user has given that permission. And for the other parts, I just mentioned that only the roots can change. If I try to change the owner of the file, hand over to the other guy, which is the test user, to test file, it wouldn't work because I'm not allowed to do that. It's only the roots that can do that, hand over a file. So we go back to the slide. So, sorry, I have to go back. Okay. Yeah, I'm there now. So, I'm missing my mouse is lost. So I'm looking for it. Okay. Yeah, there it is on the other side. It's back. So the file permission continue on. So we have, now this is the absolute mode, this is the God mode where you feel like, so this one is that it's not user friendly, but it also works. So where you change the arrow to numbers, which is an octal, the permissions are in octal, what do you call it, so number mode. So it's octal where that's 4, 2, and 1 is equal to, wait, yeah, read, write, execute, yes. So it's equal to 7, and the sticky bit makes it 8. So it's an octal, it cannot pass 8. It's a number from ranging from 0 to 8. So the read is 4, and the write is 2, and the execute is 1. So if you add 4 plus 2, it's 6. When it's 6, it means both read and write. If you add 4 plus 2 plus 1, it's 7, which means the identity has read, write, execute. So for each column and user, you can set values from 0 to 7. So yeah, if you just calculate that, you want to give a write access, it's just 4. If you want to give a read and write, it's 6. So if you want to give all of them, it's 7. So when you see a folder of 5777, it's everyone do as you like. Yeah, this one is also the one I'm promising. Let's 621. When I had to make this tick, I remember when I learned it, I had to actually mention it so I get used to it. 421. That's 421. So if you're looking at 7, you just do the calculation. 7 means you have the whole access. So if you give 4, means it's only the read access, and then 2 for write.
So that 7
is the user, and you block other people. Yeah, 700 means the user can do everything, but others, both the group cannot do other things. So let's give a real example of this. And we go here to say, let me change, since I'm the owner of the file, I could change, to say that I need to give 700, like you mentioned, to this test file, test user. Okay, sorry, it's key on, I should do key. Let me clear everything up. Then debug. So now I have this. See, I've cleared all the edges. It's only the user has everything. So now, if the other user tries to do anything, it wouldn't work any longer. So you can change the number as much as you want. 777 is everything. So that's for the number. If I actually recommend the number. I don't know why, but actually I know why, because when you are programming in other languages to do it, you wouldn't put a read write the ROXW or whatever. So they specify the native programming side, the system call specify this. But if you're not a programmer, just use the user one that's easy. The read write is the key. So okay, so we move to the next slide. So the numeric mode continues. Just said we have the 755, and it gives 755. Now it's what someone can guess. What is 755? Just to make it interactive. So, okay, yeah. So who has it in this index.html? Who has what permissions? So we have 755 on the file. It's for the owner. So the 5 and the further 5 is for the other. Okay, so that means that the owner can execute, read, and write this file. The group can only 4 plus can only read and write. Read and write. No, wait, 421 here. It's 5. Read and execute. Yeah, they can read and execute, but they cannot write to the file. So the same with the others. So we see that here, and also we have also the 644, which is 4 plus 2, read and write. Then the user can read and write, but they cannot execute. The 4 is only read, others can read it, but they cannot write, they cannot execute it. Yeah. So we continue the 2 critical points. Okay, so yeah, the permissions for directories, it was confusing for me at first, so I have to make it clear. For directory, it's not like a file. To read the content of directory, you don't need a read permission, you need an execute permission. So directories are like, let's say, just take them as programs. They are being executed to get an output. So to see the content of a directory, you have to execute that directory. So what you need for me to give another person access to my directory is execute access. So if you, like I said, the permission of a directory affects whether a person can see it or add it. The permission of a file, that means the person can add the data into the file. So now in directory, where the write permission comes in is when the person wants to write into the directory. But to read the content, I think it executes. So let's just try it out because it confused me a bit when I was starting. You know, in the programming, it doesn't end. There are times you still Google basic stuff. You still Google basic. so, so let's see that we are creating a directory. So make directory and call it test directory. So we have the direction, we see the permission. Okay, no, I think I have to append, to see these, I have to append Z. No, it's not C. There is one. Sorry, D, not C. Yes. So here we see it's a directory. The D at the end is no longer a dash. So we see that the directory as a user have a read write execute. Now as a guest or others, I have only read and execute. So let's see what I can access as an other person with this permission. Well, let me say test directory and so I can do ls or d test directory. I can see the file. Let me see if I can see the contents. And then so I can see the content as well. It's empty. That's because I have a read and execute. So let me remove execute to test the theory. So I can say this user is chmod others minus execute test directory. So that removes me. Sorry. Yes, let me see if I can read it. Okay, I can read it actually. So this is the contents of the file, and to write to it, let me remove. Okay, if I try to write to it, let's say from touching a file, test directory, file 1. Yeah, I cannot do that because I don't have permission to write to it. So so that my first guess was wrong, because I could read it without the executable. I've forgotten where the case comes to be for executing a directory. But let's continue with the test and say that we are giving it, let's restore the execute, and then plus it. And this, I'm sure this doesn't mean that I can write to it, but I can still read it. So I cannot write, so we give it a write permission here. And say the other can write. So if I do this, now I can write to the file, and if I do the ls, I'll see that there is file 1 inside there. So this is the file I've created, and because it's granted the test user or other users permission, I created a file with my own file. And this is the very tricky part of it, is that I that owns the folder, I cannot modify his file. He created his file in my folder because I granted access, but then it doesn't mean I have access to this file. He can change the permission. So let's see. We can try it as well. We see that we have file 1 created by test user. So the owner of the file, which is me, then Jajo, let's say we see that the test directory, let's see our test directory. Okay, it's owned by test user. I'm going to try to remove a read access from the owner of the file or write access. So as another user that created the directory. So let's say chmod the user u plus u minus read and write. Yes, sorry, it was it's a mistake. So u minus read and write. That's the owner of test file, test directory, and test on file 1. Let's see if this works. No, see, but it's my folder. So it's my folder, but it stops you because I don't own the file. And so the only thing that happens is I I also don't think I can change the permission because I didn't create it. So he owns the file, whatever. But I can delete the file.
What?
That's where execute comes. I can delete content from the file. So I could delete this file. Let's try. Remove this directory. Sorry, file one. No, it's not empty. Yes. I can delete the file. It's my directory. I can delete. So I can delete the file. It's my directory. It's mine, but the file is another person. Yes, there is. But also, he created, I cannot change his file permission, but I could delete his file. I think that's where the executor, I know that it bothered me at some point. If you remove the executable access, you cannot delete file from the directory. Let's try and see if my theory is right. So now we have deleted this file and say, this guy has his file lost. Let me create it again. So let me create the file again, touch file one. And then let's do the think. I wish this table was facing like this. So I can just sit down and like you type in. So we see that, actually I can do that. But I'll be backing you for a while. Yes, this is also good. Can I do this? Because camera reaching it. No, just because I don't like I have to back you to actually type something.
You got it right.
Okay, yes, this is better. Okay.